We're going to continue on with curves, and I'm going to talk about stationing, because stationing was invented a long time ago before people had calculators and computers and things, and it's a really good way to keep track of distances with simple arithmetic, and that's all it is. So anyway, we established for the PI a station of 35 plus 00.00. That means it's 3,500 feet station, 100-foot station, so 3,500 feet, 0.00 feet from the beginning of the project. Now, because of that, you know, since the tangent length is 1,006.92, simply subtract 10 plus 06.92 from 35 plus 00.00, and you end up with station 25 plus 4308. Now, to get your stationing for the PT, which is going to be the tangent stationing, this far into the project, when they're still planning it out, you don't know what the arc length is going to be because you don't know the radius. So therefore, you're still using tangent lengths. Usually it's on the center line of the road. So what you do is that you figure tangent, this PI of 35 plus 00.00, add the tangent length to that, and you get station 45 plus 56.92, and that's going to be on the plans. Now, the first thing that you're going to do after the radius is established, based on other factors like how fast people are going to be driving on this road, then all you have to do is add, since you already know the PT stationing based on tangent, you have to take this station here, add the arc length, and come up with a revised station. And if it comes up bigger than your tangent station, you made a mistake. So you start with this point here, the stationing for this point, add your arc length, and that's 1675.52, and you come up with a revised station of 42 plus 18.60. Now, what is the angle? You already know the distance from this point to that point. What is the angle going to be? Well, the angle for the staking of this point, back-sighting this point, you're going to sight on that point, occupy that point, and then turn an angle right. And then that angle that you turn is always going to be 1/2 the central angle. And that's true of anywhere along this arc when you're set up on that point. So anyway, the first thing the contractor is going to want you to do out there is to get on even stations for him to work with. So first, well, you start with 25 plus 4308. You need to get to station 26 plus 00.00. To do that, it only takes arithmetic. From 26 plus 00.00, subtract 25 plus 4308, and you get 5692. That's the arc length that you need to do your calculations. You've got a 1,200-foot radius. Take the arc length, 56.92, divide by 1,200, and you get, let's see, 5692 divided by 1,200, and you get this little tiny figure of 0.0474333333. That's your radian angle measurement for this central angle. Now, you don't have to worry about your, you've already figured your angle for turning from this point to get to that point. So all you have to do now is come up with a chord distance between these 2 points. And you're going to find out when you do the math that the chord distance is almost exactly the same as the arc distance. It's going to be like that for all teeny tiny angles like this. You've got a 1,200-foot radius and 56.92 feet here. So you come up with 0.04733333, etc. Anyway, that's your angle what is your formula? And the distance is radius times 2 times the sine of the central angle over 2. So simply you stay in the radians that you already got and then divide that by 2. Enter 2 divide, and you get that. You get the sine, convert that to degrees, minutes, and seconds. Or excuse me, degrees. And you get that. Get the sine of that. Multiply that by 2. Multiply that by 1200. And you get 56.91, exactly 1/100th difference. But anyway, that's the formula that you use to get at the chord distance. Now, the contractor is probably not going to pay you to stake every 100 feet unless he's just rolling in money, which nobody is nowadays. So what you need to do, let's just say that he wants even station and then every 300 feet along the curve. All you have to do is add your arc lengths together. So he wants even station, 2600, plus a 300 foot, 1, 2, 3 along there, and add 300 to 56.92, and you get 356.92 G. Now divide that by 1200. And you get 0.297, etc., etc. That's your central angle in radians. Convert that to degrees, and then convert that to degrees, minutes, and seconds. You have a central angle of 1702.30. Well, that's nice. That tells you if you take that and divide that by 2, you come up with 8 degrees, 31 minutes, and 14.9 seconds. That's your staking angle. And your distance is going to be, distance is equal to 1200, the radius, times 2 times the sine of that central angle, which is formed by the 56.92 and the 300. That's the arc distance. So it's 1200 times 2 times the sine of the central angle divided by 2. In which case you come up with a chord distance of 355.60. And that's the magic distance here. And you'll notice that it is not like the arc distance. It's more than a half a foot. Yeah, it's about a half a foot difference from 355.60 to 350. Oh, more than that. 1.3 feet. Anyway, that's the difference between the chord and the arc distance. You stake the distance with the chord, and you stake the angle from the central angle, half the central angle, and that's all there is to staking a curve. And the numbers just get bigger, and the differences get bigger between the arc and the chord the further along you get. So that's all there is that we need to worry about for staking a curve for the time being. And going to have some homework exercises for you. I think I'm going to have less than I originally planned, but this is our final segment in the survey math. So I hope you've enjoyed this, and it's been a learning experience for all of us. So that's it for curves for the time being.